Welcome to Calculus 30. This is lesson number 1, and it's just a short intro as to what is calculus and why are we taking calculus, and what's the big deal about this hard math that's called calculus. Well, when we talk about calculus, we're actually talking about a separate branch of mathematics. So the reason why it's not called a math, whatever number it is, I mean it is in universities, but we call it calculus because it's a new kind of math. It's different from everything, all the other kind of basic algebraic math and that sort of thing has led up to the basis for this new kind of math. And of course, Sir Isaac Newton and Gottfried Leibniz were the co-creators of calculus, and they had each individual did slightly different methods of calculating one main thing, and that was an instantaneous rate of change. So a very exact number for a change at an instant in time. And they dealt with things called infinitesimals and little tiny bits, and how the tiny bits kind of inch towards a value and different things like that. So calculus is a special kind of math, and it helps us to do two main things. And the brief introduction here to calculus, that it's separated into two different categories. One is called differential calculus. And in differential calculus, we are focused on instantaneous rates of change, or just rates of change, but more specifically, instantaneous. Now you see this red line right here. This red line is called a tangent line to this black curve. And the slope of the tangent line gives us an indication as to how this graph, the black graph, how it's changing over time. Okay? And the time, of course, is very short. It's a very short amount of time. And so it's called an instantaneous rate of change. The slope of this tangent is an so it's a rate of change at one specific point. A tangent is a line that touches a curve only at one point. And so it's this point right here. And maybe I'll zoom in there for you so you can kind of see this. But you see how this red line touches the graph at one point. Yeah, it touches over here, but we're not talking about this point. We're talking about this small area right here. And so that is an instantaneous rate of change. Now, the tangent line, all right over here, let's say, would be a red line. If we just extended that, it would be a line that would look like this. And so if you consider how this is changing, this black graph, it's coming down, so it's decreasing. But then at this point right here is when it is neither increasing nor decreasing. And so a tangent line with a slope of 0 would indicate that its instantaneous rate of change at that point would be 0. So this is differential calculus, studying what's called the derivative. And the derivative is something that we're going to learn very shortly, but it is basically the slope of a tangent line to a curve. And obviously that curve is going to represent things like position versus time or something like that. And so it's going to give us an instantaneous position divided by time, or instantaneous speed, and there'll be other applications. So that's the first half, differential calculus. The other half of calculus is called integral calculus. Integral. And integral calculus is focused on, really, if we look at this graph, the integral for this graph between a and b, and that's the notation down here that we'll study a lot later in the course. The integral between a and b for this function f of x with respect to x represents the area under the curve. Now, integrals are not always area, but over here in differential calculus, we're talking about the instantaneous rate of change at a point. Here we're talking about the area underneath the curve, which could represent a whole bunch of different things than an instantaneous rate could. Okay, so if we're talking about speed versus time, this could be the distance traveled, or we're talking about the movement of populations or something over time, right? Anyways, there's lots of different applications, but the two main branches are integral, differential, and integral calculus. Okay, so I want to move to the next slide here, and these are skills needed for calculus. So you might be wondering, well, what if we're doing the new calculus, this new kind of math, what do I need to know? Well, as I said, there's a lot of algebra graphing, factoring, all this sort of stuff that leads into calculus. That's the basis for understanding and applying the calculus. So what are some things that you need to know how to do? Well, these are things that you've studied in all your pre-calculus classes, and that would be sort of things like this, like exponents, okay? So what do exponents have to do? How do you work with exponents? Factoring is obviously very, very huge, okay? Greatest common factor, factoring all sorts of polynomials, all right? Rationalizing we'll talk about very shortly, the numerator and the denominator. So rationalizing is basically eliminating radicals that are in a function, or in specifically a rational function. You want to make it rational without the irrational parts. Simplifying expressions, solving algebraic equations. Okay, simultaneous equations would be like systems of linear equations and that sort of thing, systems of equations. Graphing, okay, so being able to understand a graph and to graph lines, okay, obviously understanding slopes and that sort of thing. Those are kind of things that we've studied in pre-calculus. Conic sections, not that big of a deal. In advanced calculus, we're going to talk about, things like that in a little more depth. But the one you should know, obviously, is parabola there, right? We don't do a lot of study on the others in high school anymore, but the parabola we do a lot of study on, and that is called a conic section. Functions, okay, domain and range, obviously composition of functions. A little bit of inverse of functions. We'll study that a little bit in calculus as well as we do our review. Basic shapes, you talk about transformations, pre-calculus 30. There's a big part about transformations there. So you got to know about that. You got to be familiar a little bit with absolute value and those kind of absolute value functions as well. Higher order curves, so cubic and quartic functions and that sort of thing we'll deal with. Piecewise functions, you have a little bit of exposure to that in pre-cal 30 as well. Test for odd and even functions, so test for symmetry. That is something that, if you don't know about that, that's okay. We'll introduce that during this class. Okay, what else? Pythagorean theorem, area formulas, volume, similar triangles and proportions, all this stuff that we have covered and is going to be needed to build onto. So we're going to need to know a little bit about log and exponential functions. Again, we'll do some review and preview as we go through the course. So not to worry about it if you aren't that good at this kind of stuff yet, or if you don't really remember everything. We are going to talk a little bit about this as we move through it, but these are some of the things that you should have some exposure to, of course. And trigonometry is another big one. The unit circle, you remember that from pre-cal 30. We're going to need to use that at unit circle. Pythagorean identities. Okay, this was a chapter 6, I believe, in pre-cal 30 as well, and we're going to be reviewing those, so we'll have to know about those a little bit. We're not going to prove identities so much, but we're going to need to understand the identities that are used to prove. Solving equations, inverse trig functions, I'll talk to you a little bit about those. You don't have to know too much about those right now. Right-angle trigonometry, obviously, and graphs. And this point number 6 here, limits, you don't have to know about that coming in. That's not really pre-knowledge. I'm going to teach you about the limit very shortly here when we get into chapter 1. Okay, so again, that's a little bit of what probably you should have a pre-knowledge of coming into calculus. And if you need any help with any of this, if there's something you haven't heard of, please let me know, and we can go over that. I am going to go over just real briefly here the functions that are important for calculus, that we know what these kind of functions are. And it's a little bit of it's called a toolkit of functions. So we need to know what a constant function is. Y equals, let's say, something like 3. Y equals 3 would be a straight line going through y equals 3. And so this would be the function y equals 3, or f of x equals a being 3. Okay? And whatever. So it's a horizontal line if you just have y equals some constant. Okay? A cubic function is something like y equals x cubed. And it's generally shaped like this. If we have y equals negative x cubed, or f of x equals negative x cubed, then we have something that looks like this. It is flipped kind of about this y-axis here. Okay. The identity function is y equals x. We're going to use that a lot. I'm going to refer to that. Inverse of functions is a big one. But it's basically y equals x, so you have 2, 2 as a point, 5, 5 as a point, -5 comes with -5, all that sort of stuff. So it's just this straight line where y and x are always equal. The square root function, okay? Again, okay, so now we're getting into functions that are a little less common, but the square root function basically means this. If you have a number like, 1, x equals 1, the square root of 1 is 1. So here's the point, 1, 1. If you have the next perfect square would be over here at 4, okay? And so the square root of 4 would be 2. So if this is 1, there's 2, you see that? And so you see that this graph kind of grows and kind of, starts to flatten out a little bit and, kind of is this sort of shape, right? And so that's what a square root function would look like. Obviously, it doesn't exist below 0 or less than 0 because the square root of -1 is not a real number, so we can't graph it on a real number graph. So there's nothing here below y equals 0 and nothing below x equals 0 as well, okay, less than that. Absolute value function, okay, y equals the absolute value of x. This would be the same as y equals x, except for any part that is negative, the absolute value signs would make them positive. So this would be reflected up here. Any negative value would be made positive and so on, and so you get this little V shape. This is y equals x, this is y equals negative x, okay, if you compare it to y equals x function, that sort of thing. Got it? Okay, so let me just kind of get rid of this kind of stuff over here, but greatest integer, okay, this we'll talk a little bit more as we get along here, but this is sort of an integer function, meaning the x value is between 0 and 1, it's just 0 the whole time, it doesn't change incrementally, it stays as an integer, it never goes into the decimal parts, and so between 0 and 1 it's always 0, and then when it hits 1 it instantaneously flips up there to 1 and is 1 the whole time until 2, and so on. So you get this stepwise function here, okay? Y equals 1 over x function, okay, if x is 1, then y is 1 over 1. If x is 2 over here, y is 1 over 2. And so you see how as x gets larger, 1 over x gets smaller. As x gets closer to 0, 1 divided by 0.001, let's say, would be, what was I say, 1,000. So 0.001 is way up here, 1,000, like off the charts. So that's why it kind of races towards a really high value up here, okay? So that's what this kind of looks like, and the same in the negative. An exponential function, like y equals, let's say, 2 to the power of x, where a is, here's a constant. It looks like this. If x is 0, y is 1, so that's a common aspect there. And then, of course, if x is 1, 2 to the power of 1 would be 2. If x is 2, 2 to the power of 2 would be 4. So you can see how it jumps exponentially. Okay, that's where we get that expression from. It goes exponentially. And the other way, okay, as x becomes -10, let's say, well, 2 to the -10 is a very, very small number, right? That's 1 over 2 to the power of 10. So it's a very, very small number, so that's why this black line starts to come closer and closer to 0. It never touches 0, but it always comes closer and closer and closer and closer to 0, the further back you get here in negative. Okay, quadratic, I won't talk too much about that. You know about a parabola. Logarithmic, this is actually the inverse of an exponential. Okay, and this too, you might not recognize this ln. You probably are familiar with this, log of x, right? Well, ln, we're going to find out in later chapters here, as we move through calculus, you're going to find out that ln is a logarithmic function. It's the natural logarithmic function, and it has a special base. Log is base 10. Natural logarithm has a special, different base that is really handy for calculus, and there's a whole lesson on that, and it's awesome, and you'll find out about that later, but this is a logarithmic function. And so if you take an exponential function, okay, like y equals 10 to the power of x, the inverse of that, if you flip around x and y, you get the log function. So this looks very much like an exponential function. It does look a little bit like a square root function as well, but they're not the same, okay? A little bit like that, but they're not the same. So anyway, so this is sort of your, this is the functions. Now there's lots of other stuff that we, should go over before we head into calculus, like the unit circle, if you remember the unit circle. I won't take the time here to show you all that, but you should be familiar with the unit circle, whether you love it or you hate it. from from previous classes. The unit circle is something we're going to use extensively. And then the other thing that we're going to look at here as we move through is factoring, of course. So basic factoring of a binomial, let's say, factoring of a quadratic, okay, here, another quadratic here. So these are all examples that we will go over again in class, but you can kind of see that I've done this before for a different class. Difference of squares, right? If we have a difference of squares, you should be able to factor that. And also a difference of cubes and sums of cubes too, we're going to look at in the review and the preview section leading up to calculus section 1.1. Okay, so this is what we will take a look at very shortly. And you can check out video number 2, review and preview to calculus video number 2, and I go over these examples if you want to see them in a little more detail. Simplifying rational expressions, factoring, dividing out common factors. Here's an example of rationalizing. We want to get rid of this radical here, and the way we do that is multiply by something called the conjugate to get rid of the radical there. And usually we can only rationalize either the numerator or the denominator, not both of them at the same time usually. Okay? And there's some work for you to do if you're studying along with the Stewart Calculus text. Okay, so that's the review and introduction to calculus. And remember the two different parts. The first, the big part of this course is going to be the differential calculus. We're going to spend a lot of time on differential. The integral comes really close to the end because this is the bulk of what we're learning in high school. Okay?